Hello everybody. In this question, we have to answer what are electromagnetic waves. Now, this is a very simple theory-based, knowledge-based question. So let's start writing all the things that we know about electromagnetic waves. So first of all, what are electromagnetic waves? So any wave which is produced by an accelerating charge particle are known as electromagnetic waves. So what is the cause due to which electromagnetic waves are produced? So any wave which is produced due to an accelerating charge particle, accelerating charge particle are called electromagnetic waves. Now, electromagnetic waves are basically transverse waves. Electromagnetic waves are transverse waves. Also, one important properties of electromagnetic waves is that they are non-mechanical in nature, which means electromagnetic waves do not require a medium for their propagation. They can travel in vacuum also. Apart from these, uh, electromagnetic waves, they all travel in vacuum at a constant speed, which is equal to speed of light. So the speed of electromagnetic waves in vacuum is given by C is equal to 3 into 10 raised to power 8 meter per second. Further, if we want to write a few more points about electromagnetic waves, is that in electromagnetic waves, both electric field and magnetic field vibrate perpendicular to each other. So, electric field vector is perpendicular to magnetic field vector, and they both are perpendicular to the direction of propagation of electromagnetic wave because they are transverse in nature. Uh, Moving on, if the refractive index for a particular medium is mu, then in that medium the speed of electromagnetic wave v is given by c upon mu, where mu is the refractive index for that medium. So these are the various properties of electromagnetic waves. I hope this question is clear to all of you. Hello everybody. In this question, we have to write the integral form of modified Ampere circuital law. Now, this is a very simple question. We know that whenever electric field in a region is changing, an extra displacement current is also produced. Now, if we wish to include this displacement current, then the Ampere circuital law, which we studied in magnetic field, will be modified just a little bit. So to answer our question, the modified form of Ampere circuital law is written as integral B dot dl over a closed path is equal to mu naught times IC plus ID. Now in this equation, IC is the conduction current and ID is the displacement current. We know that displacement current is produced due to varying electric field in the region. Now we know that displacement current is equal to epsilon naught times rate of change of electric flux. Rate of change of electric flux can be written as d by dt of phi e. So if I put the value of id from this equation into this equation, we get the modified form of Ampere circuital law as integral b dot dl is equal to mu naught times IC. I am writing just as it is, and ID I am putting the values of epsilon naught times d by dt of electric flux phi e. If we simplify it, then we get our final answer. Integral b dot dl over a closed path is equal to mu naught into IC plus mu naught epsilon naught d phi e by dt. Now this final equation is the modified form of Ampere circuital law. Hence, this should be our final answer. Hello everybody. In this question, we have to write a short note on the Gauss law in magnetism. Now, Gauss law in magnetism is a very simple concept. It states that integral B dot dA over a closed surface is always equal to 0. Now, this mathematical statement is known as Gauss law in magnetism. It states that the flux of magnetic field over a closed Gaussian surface is always equal to 0. Now we can imply a few more things with this Gauss law in magnetism. Now, since the flux of magnetic field through a closed surface is 0, we can surely say that the number of magnetic field lines entering and the number of field lines exiting the closed surface will be same. So we can conclude that the first conclusion could be that the magnetic field lines always form closed loop. Magnetic field lines will always form closed loop. And since magnetic field lines are forming a closed loop, we can also conclude that magnetic monopoles cannot exist. So the second conclusion that we can write on the basis of Gauss law in magnetism, it will be that magnetic monopoles cannot exist. Monopoles cannot exist. So I hope the Gauss law in magnetism is clear to all of you. In this question, we have to write two uses of infrared radiation. So first of all, infrared is that part of electromagnetic spectrum which is produced by hot bodies. So first of all, we should know some common things about infrared radiation. So the first thing is the range for the wavelength. So the range of wavelength for infrared radiation lies between 8 into 10 raised to power minus 7 meter, and it goes up to 5 into 10 raised to power minus 3 meter. Now, according to this range of wavelength, the frequency can lie between 4 into 10 raised to power 14 hertz, and the lower limit can be 6 into 10 raised to power 10 hertz. So these are the basic things that we should know about infrared radiation. Now coming on to the uses of infrared radiation. So first of all, infrared radiation it provides electrical energy to satellites by the means of solar cells. So the first use which we should keep in mind is that it is used in solar cells. It is used in solar cells. Secondly, it is used in greenhouses to keep the plants warm. So the next use is that it is used in greenhouses to produce the greenhouse effect. Moving along, the next use which we should keep in mind is that it is used in heat therapy for muscular pain. Okay, so the fifth point I'm writing is that it is used in heat therapy. Second, next use, it is used in TV remote, the remote of a television that we use also frequently. Infrared radiation is used in that. Okay, and lastly, infrared radiation is used in night vision. Whenever we need night vision, we use infrared radiation for that. So I hope this question is clear to all of you. Hello everybody. In this question, we have to write about the two uses of microwaves. About microwaves, we know that it is a type of transverse wave, which is also a part of the electromagnetic spectrum. In this question, we write. Hello everybody. In this question, we have to write about the two uses of microwaves. About microwaves, we know that it is a type of transverse wave, which is also a part of the electromagnetic spectrum. Now, some of the most common uses of microwaves I'm mentioning in front of you. The most common use of microwaves is in the radar system for aircraft navigation. So the first use we can write it is used in radar systems for aircraft navigation. And the second most common use of microwaves is a very long wireless communication through satellite. So we can write it as the most common use of microwaves will be in wireless communications. So the two most common uses of microwave are in radar system and in wireless communication. So I hope you clearly understood the question. In this question, we have to write the two uses of UV radiation. Now, this is a very simple knowledge-based question. So let's go ahead and start solving this. The first and the most important use of UV radiation is in disinfection purposes. Disinfection purposes. What is disinfection? If we want to destroy bacteria or viruses from a surface, then we use ultraviolet radiation for that. For example, if we want to kill bacteria in our drinking water, then ultraviolet radiation is passed through a sample of water and it will kill all that bacteria present in that. Furthermore, one more example for disinfection is that if we want to clean out our surgical instruments after a surgery, for that purposes also ultraviolet radiation is used for disinfecting or sterilizing the surgical instrument. So the most important use for ultraviolet radiation is in disinfection of surfaces. Second, the second use for ultraviolet radiation can be that it is used in microscopes for studying atomic structure. So we can write the second use as that ultraviolet radiations are used in microscopes. So basically, UV radiation can be used in microscopes to magnify an atom and then to view and study it properly. So these are the two uses of UV radiation. I hope these are clear to all of you.